In the vast expanse of the universe, there exists a star unlike any other, a giant of the universe known as Betelgeuse. But behind its majestic appearance lies a ticking time bomb, ready to unleash a monstrous spectacle that will shape the very foundations of our understanding of the world. How do you think humanity should prepare for such a massive heavenly event? And how exactly would Betelgeuse's explosion reshape our understanding of the universe? Join us as we unravel the mysteries of Betelgeuse. In the vast expanse of space where stars are born, live, and eventually fade away, there's one star that's been causing quite a stir among astronomers and the public: Betelgeuse, a big red supergiant located prominently in the group of stars known as Orion. Betelgeuse has always awakened our curiosity with its sharp red glow and its tendency to vary in brightness. But lately, there have been some interesting developments that have heightened our interest in this heavenly giant. Betelgeuse is an absolute giant, approximately 764 times larger than our Sun. Imagine a star so huge that if it took the Sun's place, its surface would stretch beyond the path of Mars, swallowing up Mercury, Venus, Earth, and Mars altogether. But its immense size isn't just a random fact. It's a clue to where it stands in its life cycle. As a red supergiant, it is in its declining years, expanding and cooling down after a lifetime of burning hydrogen into helium in its core. Betelgeuse, at around 8 to 8.5 million years old, might sound young compared to human standards, but in the world of stars, it's ancient. It's seen more than its fair share of heavenly drama over the years. Born from the otherworldly fire of a stellar nursery, it emerged as a hot, luminous blue star radiating with intense energy. But as the years passed, the star underwent a profound transformation, evolving into the huge red supergiant we marvel at today. This transformation is proof of the relentless interplay of two heavenly forces, nuclear fusion and gravity, within the boiling core of Betelgeuse. Hydrogen atoms fuse into helium, releasing staggering amounts of energy that power the star's brightness. Yet, as the star exhausts its nuclear fuel, gravity applies its unstoppable pull, causing its outer layers to expand outward in a planetary dance. Unlike the Sun, whose surface blazes with a fiery yellow-white brilliance, Betelgeuse's cooler temperatures are injected with a more subdued brightness, radiating warmth and mystery into the universe. But its story is not merely one of static brilliance. It is a narrative of change, marked in the record of human history. Ancient texts from cultures spanning the globe speak of Betelgeuse's shifting colors, with accounts of the star appearing yellow in ancient times before transitioning to its current blood-red appearance. This shift offers a window into its heavenly journey, a journey that continues to unfold before our eyes. Amidst Betelgeuse's heavenly beauty lies a mysterious flash, a variability in brightness that has puzzled astronomers for centuries. As a semi-regular variable star, its brightness level retreats and flows in a mesmerizing superterrestrial dance, casting its radiance across the heavens in a rhythmic tempo. Its rhythmic cycles, carefully observed since the 19th century by astronomers like Sir John Herschel, unveil a heavenly choreography that echoes through the record of time. However, Betelgeuse's heavenly dance is not merely a tale of regularity, but a saga of irregular impressiveness, punctuated by unforeseen twists in a space spectacle that shook the foundations of astronomical understanding. Betelgeuse unveiled its great dimming in late 2019, casting a face of mystery over the night sky. This red supergiant, a space light in the Orion group of stars, embarked on a journey of space transformation, discarding its bright cloak with each passing day. The star's brightness reduced at an unprecedented rate, growing dark by 0.1 magnitudes per day until it reached its lowest brilliance in February 2020. This heavenly drama, visible even to amateur astronomers, sparked a wave of speculation among astronomers worldwide. While Betelgeuse's fluctuating brightness is not uncommon, the magnitude and duration of the dark event left scientists grappling for answers. Was it on the brink of a disastrous supernova explosion? Or was this merely a temporary heavenly irregularity? Traveling across the vast expanse of space at the speed of light, its brilliant light embarked on a heavenly journey spanning approximately 725 light-years before reaching our eyes. Amidst the cosmic tension of Betelgeuse's fluctuations lies a series of unanswered questions, inviting astronomers and skywatchers alike to ponder the mysteries of the universe. In a quest to unravel the mysteries of Betelgeuse's enigmatic behavior, Andrea Dupre, esteemed Associate Director of the Center for Astrophysics at Harvard and Smithsonian, embarked on a space journey with her team. Armed with the unparalleled capabilities of the Hubble Space Telescope, they embarked on a 3-year endeavor to examine carefully the outer reaches of this heavenly monster. The observations offered a tantalizing glimpse into the dynamic interplay of its space dance. Like a cosmic heartbeat, it expands and contracts, organizing a harmony of bright fluctuations. Exploiting Hubble's sensitivity to ultraviolet light, the researchers delved into the star's atmospheric intricacies, unveiling a mesmerizing variety of turbulent convection cells. Analyzing a series of spectra captured throughout 2019 and 2020, Dupre and her team uncovered the intricate dance of material within Betelgeuse's celestial territory. Focusing on magnesium-2 lines, they decoded the atmospheric harmony, revealing material hurtling at breakneck speeds of 200,000 miles per hour from the star's surface into its outer reaches. This space evacuation of hot, thick material extended across millions of miles, signaling the birth of a majestic dust cloud that covered Betelgeuse in its lovely embrace. Dupre's calculations revealed that an unprecedented surge of material, twice the norm, emanated from Betelgeuse's southern hemisphere over 3 transformative months. As the dust settled and emerged from its cosmic cloak, astronomers marveled at the celestial spectacle, humbled by the intricate dance of stellar forces that govern our vast and wondrous universe. The significant mass loss from Betelgeuse, while not uncommon for stars, was particularly noteworthy given its magnitude, far surpassing the rate of mass loss observed in our Sun. This sudden shedding of material, coupled with the subsequent darkening of its brightness, ignited real discussion among astronomers worldwide, fueling speculation about the star's fate. Astronomers pondered whether this dark event could bring the long-awaited spectacle of a sensational explosion, an event of unparalleled magnitude that would offer humanity a front-row seat to observe the birth and demise of a stellar giant. Yet amidst the speculation and excitement, one question loomed. What does this dark light foretell for Betelgeuse's future? Is it a sign of an imminent explosion of the star, or merely a short-term irregularity in the star's illustrious planetary journey? Various theories emerged to explain the enigmatic dark phenomenon. Some believed that the dark light signaled a crucial phase in the explosion process, fueled by the prevailing belief that Betelgeuse is nearing the end of its existence. Others believed that a thick dust cloud, perhaps originating from the star's material, covered its brightness from our earthly point of view. The third theory looked into changes within its photosphere, the visible outer layer of the star, speculating that alterations in its composition could affect its brightness. To untangle the planet's difficulties, astronomers turned to various observational techniques, including spectroscopic studies that revealed a marked decrease in Betelgeuse's effective temperature. These studies unveiled a fascinating revelation. Its dark light coincided with a substantial drop in temperature, hinting at the presence of a huge dark spot on its surface. With each revelation, the planet's puzzle of its dark event began to unravel, offering tantalizing insights into the complicated work of heavenly events. Ultimately, the mystery surrounding this extraordinary event was decoded with the invaluable aid of the Space Telescope. Humanity's watchful eye on the universe, through its unresolved gaze, unveiled the probable catalyst behind this dark light. A big explosion of red-hot material into the vast expanse of space. This released material combined to form a thick dust cloud, covering a segment of its surface and consequently reducing the amount of light reaching us from the star. This dust cloud was believed to have originated from superheated plasma erupting from a massive convection cell on the star's surface and then migrating through its searing atmosphere towards the outer cold layers. As this plasma cooled and diffused, it condensed into tiny dust particles, uniting to form a veil that covered light from approximately a quarter of its expansive surface. Hubble's ultraviolet light spectroscopic observations, which commenced in January 2019, played a key role in reconstructing the sequence of events leading up to its dark light. These observations captured telltale signs of thick, heated material coursing through the star's atmospheric layers. In the months preceding the darkening in December 2019, a series of ground-based telescopes also documented the star's gradual waning in brightness, particularly evident in its southern hemisphere. This material, initially releasing more brightness than its customary radiance, eventually coalesced into a dark-colored cloud as it spread outward and cooled. The prevailing hypothesis proposed that this outflowing material and the subsequent formation of the dark cloud were accountable for its abrupt dark light. The magnitude of this ejection was truly staggering, catapulting Betelgeuse into the limelight. The star unleashed an estimated 400 billion times the mass typically discharged in a standard enormous mass ejection, equivalent to several times the weight of our moon. This momentous event wasn't just significant for Betelgeuse alone. It also offered profound insights into our comprehension of stellar mechanics. But what does such a huge expulsion of material signify for Betelgeuse and the broader theories surrounding the star's fate? The ramifications are profound. Traditional theories suggest that red supergiants like Betelgeuse steadily shed mass before their explosive demise. However, the sheer scale of this ejection challenged this notion, hinting at more troubles and perhaps an unpredictable final phase for these stars. Recent studies ponder the timing of such an event, proposing that it might occur sooner than previously anticipated, possibly within a few decades. As this huge star moves through space at approximately 67,000 miles per hour relative to its surrounding planetary, it generates an arc shock related to the wave formed by the bow of a moving ship. This extraordinary phenomenon arises as the star's outer layers interact with gases and dust, offering a dazzling spectacle that underscores the star's dynamic nature and its intricate dance with the cosmic background. Studying Betelgeuse's bow shock not only provides insights into its current condition, but also enhances our understanding of how stars evolve and lose mass over time. However, Betelgeuse's recent behavior has raised eyebrows among astronomers. Observations have revealed that its surface has cooled and become less thick since the ejection event, leaving the star in a precarious state even years later. Hydrodynamic simulations suggest a link between the star's convective activities, the mass ejection, and subsequent changes in pulsation mode. This ongoing instability prompts questions about the internal mechanisms driving these transformations and their potential future outcomes. Additionally, Betelgeuse's observed rate of mass loss is significantly higher than that of many other stars, suggesting a complex interplay of internal forces. The flow driving this mass loss is partially hindered by the continuous dispersal of energy through shock heating in mass ejection. Such observations underscore the dynamic and somewhat unpredictable nature of Betelgeuse's life cycle, challenging astronomers to reassess their models of stellar evolution. However, amidst all these dramatic changes, one may wonder, is Betelgeuse on the edge of a supernova eruption? The possibility of Betelgeuse going supernova has fascinated astronomers for centuries, but the exact timing of such an event remains uncertain. Recent studies speculate about the timing of such an event, suggesting that it could be sooner than previously thought, potentially in just a few tens of thousands of years. While the exact timing of such an event remains uncertain, the recent extraordinary mass ejection has undeniably shifted the conversation, suggesting a more imminent end than previously thought. Theories now struggle with the repercussions of this massive loss of material and what it signifies for the star's stability and future. However, as the astronomical community focuses its attention on Betelgeuse, another cosmic event grabs our interest and offers a compelling comparison: the supernova SN 2023. This dazzling explosion took place in the galaxy Messier 101, affectionately known as the Pinwheel Galaxy, located just 21 million light-years away. Discovered in May 2023, SN 2023 is not your ordinary supernova. It's the closest one observed in recent memory, providing a priceless glimpse into a star's dramatic grand finale. The detection of SN 2023 was nothing short of a cosmic triumph. Kayagaki, a celebrated amateur astronomer known for his talent for discovering supernovae, first spotted this rapidly brightening spot on the outskirts of Messier 101 using a modest 235mm telescope. Once he announced his discovery, the astronomical community leaped into action. Telescopes around the globe, from those stationed on Earth's surface to the circle of the Hubble Space Telescope, swiftly rotated to capture the opening spectacle of this newborn supernova. The rush to track its brightness curve provided crucial insights into the explosion's nature and the environment surrounding the doomed star. In the troubled month following its discovery, SN 2023's behavior was carefully recorded. The supernova swiftly transitioned from relative obscurity to dazzling peak brightness in just 5 days before gradually fading, losing 3 magnitudes of brightness daily. Detailed analysis of its spectrum revealed numerous bright emission lines, evidence of the violent interaction between the expanding supernova shock wave and the gas enveloping the star. This wasn't just a star reaching the end of its life. It was a massive star collapsing under its weight as its nuclear fuel was used up, with the outer layers rebounding off the thick core in a breathtaking core-collapse supernova. What makes SN 2023 particularly fascinating is the thick shell of gas surrounding it, significantly influencing the shock wave's escape from the star's core. 2 possible scenarios could explain this thick surrounding material. Either a strong, constant wind had been shedding material from the star before the explosion, or the star experienced periodic outbursts, ejecting material into space. In either case, it's estimated that the star shed up to a solar mass of material in the last 1 to 2 years of its life, indicating that its final moments were far from peaceful. Pinpointing the source of SN 2023's explosion has become a central focus of research, looking into the specifics of its parent star and the event leading up to its final eruption. Astronomers can refine their models of how stars evolve and the mechanics behind supernovae. These discoveries offer direct insights into Betelgeuse's current condition and its potential journey toward becoming a supernova, providing a clearer understanding of the signals to watch for and how to interpret the complex behaviors of this massive red giant. Research conducted by Japan's Tohoku University suggests that Betelgeuse might currently be in the carbon-burning phase of its life cycle, which typically precedes a star's demise. Yukita Seo, the lead researcher of the study, suggests that the star's core could collapse within a few tens of years after the carbon supply is used up. However, scientists at Hungary's Konkoly Observatory proposed that Betelgeuse is still in an earlier element-burning stage. Despite these differing perspectives, there's a general consensus that Betelgeuse is poised to be the next supernova in the Milky Way. Although this tragic event may not occur for another 100,000 years, throughout history, observations of supernovae have yielded invaluable insights into the deaths of stars. The earliest confirmed record of one dates back to 185 CE when a brilliant star appeared in the sky, taking about 8 months to fade away. Since then, numerous significant supernovae have been documented, including SN 1006, which was the brightest star ever recorded in our night sky, visible from various parts of the world. SN 1054, which led to the formation of the Crab Nebula and remained visible in daylight for 23 days. The last supernova observed in our Milky Way was SN 1604, which Johannes Kepler extensively studied. More recently, in 1987, supernova 1987 exploded in the Large Magellanic Cloud. It was detected through neutrino emissions and observed across the entire electromagnetic spectrum just hours after its light reached Earth. These observations have been pivotal in developing accurate models of supernova behavior and enhancing our understanding of their role in forming stars. Betelgeuse's impending supernova belongs to a category called core-collapse supernovae, which occurs when massive stars empty their nuclear fuel and can no longer resist gravitational collapse. These supernovae are among the most powerful and catastrophic events in the universe. When Betelgeuse finally explodes, it will unleash an extraordinary amount of energy in mere seconds, equivalent to the energy our sun releases over billions of years. The energy release will mainly manifest as electromagnetic radiation spanning from visible light to X-rays and gamma rays. However, the most immediate and noticeable effect of a Betelgeuse supernova would be a breathtaking light show brightening our night sky. Moreover, witnessing the explosion of a blue star could revolutionize our comprehension of how the universe expands and the puzzling force known as dark energy. Back in the late 1990s, scientists were stunned to find out that instead of slowing down, the universe's expansion is speeding up, thanks to observations of faraway exploding stars. The Betelgeuse supernova, being relatively close in the vast expanse of space, offers a precious piece of the puzzle when it comes to understanding how fast the universe is expanding and the role dark energy plays in driving this heavenly dance. It's like finding a crucial clue in a heavenly scavenger hunt, propelling us closer to translating the enigmatic workings of the planet. Furthermore, pondering the potential repercussions of a Betelgeuse supernova on our humble planet raises intriguing questions. Could humanity be in danger? Fortunately, the huge gap of space that separates us provides a reassuring safeguard. Betelgeuse, at a staggering distance of 725 light-years away, lies over 4,067 trillion miles from Earth. It's like contemplating the vastness of an endless ocean. This vast heavenly expanse acts as a shield, safeguarding us from any direct harm caused by the explosion itself. It's as if Earth is nestled in a cosmic shell, shielded from the cosmic fireworks by the mysterious distances of space. So, the Betelgeuse supernova is a wonderful and inspiring spectacle, and Earth's safety remains comfortably assured in the grand decoration of the world.